Okay, let's have a look at solving linear and absolute value equations. I'll just fill in some of the blanks and problems as I go through. Some examples of linear terms. A linear term is anything where the power of x is 1. So for example, 2x, or negative x, or 1/3 x. Or even x over 4 is a linear term, because it's like saying 1/4 x. Or of course some kind of decimal value, 5.29x, and so on. Something that is not a linear term would be like 6 over x, because of course that's an x to the power of -1, and we need it always to be equivalent to an x to the power of +1 for it to count as a linear term. Meanwhile, a constant term is just something that's a constant, like 4, -17, a fraction maybe, 2/9, maybe a decimal, 0.18. Even something like pi would count as a constant term. Anything where the power of x is 0, all of these numbers are x to the power of 0. Okay, the key to solving a linear equation is to move all of the linear terms to one side and all of the constant terms to the other side. So although I'm going to solve it here, if my solution ends up being different from yours, or there's something that I do that you want to take a note of, please, I do expect you to write it down into this side so that your work is complete. So let's move all of the linear terms to the left. 4x is linear. Let's move over the x. It becomes a negative x. And my constant term in -1 is already on the right. Let's move over the +5 so it becomes a -5. If we simplify both sides, 3x is equal to -6. Divide both sides by 3, and we get the answer of x equals -2. Let's move on to the next problem. If you've got fractional coefficients, we can just multiply everything through by the common denominator of those fractions, and then everything will be an integer, and we won't have to worry about manipulating those fractions any further. Here I've got common denominators of 3, 5, and 2. Their common denominator is going to be 30. So if I multiply the entire equation through by 30, that means that every single term must be multiplied by 30. Don't forget every term. So -1/3 x times 30 gives me -10x. -2 times 30 is -60. 2/5 times 30 gives me 12. And 1/2 times 30 gives me 15. Let's bring all of the linear terms to one side of the equation. So that means that my 12x moves across and becomes -12x. And all of the constant terms to the other side of the equation. I've got 15 plus 60. So that gives me -22x is equal to 75. Divide both sides by -22. And I get a final answer of 75 over -22, but I don't want to write the negative in the denominator. Don't leave negatives in the denominator. You can put them in the numerator. I even prefer them in front of the whole fraction, but either one, numerator or in front. Don't leave them in the denominator. Let's do a problem with some decimals. If we've got some decimals, one good strategy might be to multiply every term by whatever power of 10 will change all of the coefficients to integers. Although multiplying by 10 to the 1, or 10, would bring this to an integer, and this to an integer, and this to an integer, because we'd be moving the decimal over one place in each. I have 2 decimal places to move over here for it to become an integer, so I should really multiply the whole thing through by 100. So that gives me, as I multiply every term by 100, -50x minus 40 equals 120x plus 11. Let's bring the linear terms to the left and the constant terms to the right. -170x equals 51, so I'll divide both sides by -170. And once again, I don't want to put the negative in the denominator. I'm going to put this in the numerator for now, because this can actually be simplified further. Dividing the top and the bottom by 17 yields -3/10. It might actually be good form to leave my final answer as -0.3, Because the problem was given to us in terms of decimals, it would be ideal to give our answer in terms of decimals. Much like if somebody asked you a question in Spanish, you would presumably answer in Spanish. However, you won't lose marks if you leave it as a fraction. Okay, if we've got some parentheses, then we've just got to expand the parentheses using the distributive property before we can begin. The 2 distributes to the x and to the 3. And the negative 3 distributes to the 1, and the negative 3 distributes to the negative x, yielding a positive 3x. That's a common mistake students make, is with the sign there. So remember that you are distributing, in this case, the entire quantity, negative 3. Simplifying each side gives me 2x plus 2 equals 8x minus 3. And now, just like any other problem, let's bring the linear terms to one side and the constant terms to the other side. Divide both sides by negative 6, and we end up with a negative divided by a negative, which cancels 5 over 6. Sometimes the linear terms will cancel out, and we have to interpret the meaning of the remaining expression. So if the remaining expression is true for any value of x, for example, if you had something like 5 equals 5, you'll notice that all of my x's are gone, but I have an expression that will be true for all values of x. Well, all values of x, that must mean that there are infinitely many solutions. And those infinite solutions in this situation, we could describe them as saying that they are all real numbers. However, if you've got your x's cancelling out and you end up with a false statement, like 2 equals 3, that of course is not true for any value of x. Thus there is no value of x that will satisfy the equation, and there will be no solutions or no real solutions. Alright, let's try out this concept with these next 2 examples. And so if I distribute, to get rid of the parentheses to begin, 3x minus 5, the minus distributes to the negative 2x, and my 5 distributes to the x and to the negative 1. Let's simplify. 5x minus 5 equals 5x minus 5. Let's bring the linear terms over to one side, and I've got 5x minus 5x, and I'll bring my constants to the other side, and I've got negative 5 plus 5. This yields 0 equals 0. My x's have cancelled out. Now this statement is true for all values of x, and therefore x can be any value at all. And I can describe this as x is all reals, or all real numbers. In the second example, let's distribute my, because I've got fractions, I tell you what, I'm going to distribute first. 2/3 x, and 2/3 times 6, that's 12/3, or 4, plus 1/3 x. And on the right, my negative distributes to the 5 and to the negative x, yielding a positive x. If I simplify each side, my 2/3 x plus 1/3 x, that's what I was hoping for, gives me a 1x. And negative 5 plus x on the right-hand side. Let's bring the x's together. So I've got 1x from the left. I bring over my positive x, it becomes a negative x. And we'll bring the constants over to the right. My positive 4 becomes a negative 4. And I end up with 0 is equal to negative 9. Now this obviously is never true. There is no value of x that will ever make this true. And therefore, x has no solutions. Or the equation has no solutions. Alright, let's go down to absolute value. The absolute value of an expression means that we are taking the magnitude of that expression. And that means that the absolute value represents the distance between the expression and 0 on the number line. So for example, the absolute value of 3 we know is equal to 3. You might think of this as simply taking the positive value of the contents, and the absolute value of negative 2 would be positive 2. But let's just look at that graphically. Here's 0 in both of these number lines. Now in my first case, I'm looking at the absolute value of the 3. In the second case, I'm looking at the absolute value of negative 2. So if I graph those points on the number line, we can see that the absolute value is representing the distance between the contents of the expression and 0. Likewise here, the distance between the negative 2 and 0 is a distance of 2 units. So that's a good way of thinking about absolute value as a distance on a number line. Well, that will help us figure out how to solve a problem like this. The absolute value of x is equal to 4. That's like saying the distance between x and 0 is equal to 4. So maybe I should just draw a quick picture of this. The distance between our mysterious value x and 0 is 4 units. Well, that can happen in two ways, can't it? I could move 4 units in this direction, bringing me to positive 4, or I could move 4 units in this direction, bringing me to negative 4. That shows us that then there are 2 values whose contents magnitude is equal to 4. And so my answer then is x is equal to 4, or x is equal to negative 4. In fact, that shows us then a good way of interpreting how to get rid of an absolute value. If we want to remove the absolute value from an expression, the right-hand side has to become positive or negative 4, so it splits into 2 cases. Another way that we could have expressed this would have been the absolute value of x minus 0 is equal to 4. And that's another good way of seeing that the difference between our value x and 0 is 4 units. So that's the distance, and we're measuring the distance between x and 0 in this situation. Here, however, we will be measuring the distance between x and a value called 2. So let's draw a picture of this. We've got 2, and we want to find out the distance between x and 2 is 3 units. So 3 units in this direction brings me to 5, and 3 units in this direction brings me to negative 1. And so the answer for x is negative 1 and positive 5. If I wanted to solve it algebraically instead of geometrically, let's use the strategy we just learned up here, that when we take away an absolute value sign, we split into 2 cases. Either the right-hand side is positive, or the right-hand side is negative. And now I can solve each of these equations. X is equal to 3 plus 2, or x is equal to negative 3 plus 2. And then we find out the same answers. X is equal to 5, or x is equal to negative 1. So it's nice to be able to solve these kinds of problems geometrically by using a number line, seeing the distance between our x and the middle point of 2, or algebraically by removing the absolute value sign and turning it into a positive negative situation. Let's do that with another problem. Now, it's best to isolate the absolute value before we split it into 2 cases. This is clearly a more complicated problem, and I'm not going to do it in a geometric fashion. So let's isolate the absolute value first. First step I can do is bring the 1 over to the right-hand side, where it becomes a negative 1. In other words, eraser, let's try that. Okay. And so 3 minus x is equal to 6. Let's divide both sides by 2. And now we've got 3 minus x is equal to, is equal to 3. Now as we remove the absolute value sign, it splits into 2 cases, so 3 minus x will equal positive 3, or 3 minus x equals negative 3. Let's solve each of these 2 equations. So I'll leave my linear term on the left, and I'll bring my constant term over to the right. Same thing here. And then we find that we've got the 2 solutions. X is equal to, I've got negative x is equal to 0, or negative x equals negative 6. And that yields the 2 solutions, x equals 0 or x equals 6.